today we're going to be looking at solving by substitution. And so we're looking at two equations, two unknowns. So you see we have two different equations and each one of them have two different variables or two things that you don't know. And so there's three ways that we can solve these. We can solve them by graphing, which we did in 8.1. We can solve them by substitution, which we're going to look at today. And then you can also solve them by elimination, which we'll look at on the next video. Okay, so what does solve by substitution mean? So if you notice this equation, the first one is just 3x plus 5y equals 26, and the second one is y equals 2x. Because this y is equal to that 2x, we can plug that in for y on this other equation. I think if I said you have 3x plus 5y equals 26, and I said y is 3, you have no problem plugging in a number 3 there and solving for x. So we're going to do the same thing. It's just that we're going to be solving for, we're going to be plugging in a 2x. So this next equation becomes a 3x plus 5 parentheses, because we're going to plug in for that y equals 26. And what goes in for y, let me do it in a different color so you can see, is that 2x. Since y is equal to 2x, we're going to plug 2x in for y. And then we just solve, so we get a 3x plus 10x equals 26. And then we get a 13x equals 26. And then divide by 13, x equals 2. So we solve for one of the unknowns or one of the variables, but you have to know both of them in order to have your final answer, because your final answer is an ordered pair. Because remember in 8.1, we could graph this, and where they intersected was your point. So we've only got half of our problem here. And so to find the rest of the problem, we plug that back into this. We plugged this equation into here, worked it out, and then we're going to plug this into the second equation. So we end up with y equals 2 times x. Well, now we know x is 2. So y equals 4. Now remember, your answer is an ordered pair, and an ordered pair always goes x, y. So 2, 4 is your answer. And so on your take-home quiz and on your test, if you don't put it in ordered pair form, I'll count off a point. I can see here's x and y and you did it correctly, but I really want it in this ordered pair form so you realize that it's an actual point on the graph. Okay, let's look at this next one. Well, the first thing you probably notice is that it has a fraction, but just remember in algebra, anytime you see a fraction, just get rid of it. So I can look at my denominators, 4 and 5, and the least common denominator would be 20. So because that's the first one they have in common, because you see your multiples of 4 would be 4, 8, 12, 16, 20, and your multiples of 5 would be 5, 15, 20. So 20 is your least common denominator. So you're going to multiply everything by 20 except parentheses, which today there's not going to be any parentheses. And then remember, you multiply and then divide. So 20 times 1 is 20, divided by 4 is 5x. Then we have minus. 20 times 1 is 20, divided by 5 is 4x, and then equals 20 times 9 is 180. Just don't forget to multiply everything, including the other side. Whoops, this is a y right here. I wrote an x. I'm sorry, that's a y. Okay, and then we still have our y equals 5x. So we're going to take this 5x and we're going to plug it into the other equation for y. So it becomes a 5x minus 4 parentheses equals 180. You always put in a parentheses for whatever you're plugging it in. And then since y equals 5x, I'm going to put a 5x in right there. So I get a 5x minus 20x equals 180, or a negative 15x equals 180, or 180 divided by 15, I'm just over here on my calculator, is negative 12. Whoops, sorry. So we would divide by negative 15, x equals negative 12. But remember, we're not finished yet. We have one of the answers. We have to find the other answer by plugging it back in there. So we have to say y equals a negative, so 5 times negative 12, or y equals a negative 60. So your answer is parentheses, -12, -60. Remember, it's an ordered pair. It's actually a point on the graph if you graph those. Okay, let's look at one more. So we have 3x minus y equals 4 and -9x plus 3y equals 12. And so these two here were already solved for y. And so if they're already solved for y, then substitution is usually the easiest way to do it. If they're not solved for y, then you have to solve one of them for y before you can plug it in, or x. It doesn't matter which you can solve for x or y, just all these seem to be y. Or otherwise, elimination, which we're going to learn on the next class, is usually the easiest. So if you look at all these, all of them have a number in front except for this y right here. So that would be the easiest thing to get by itself. And so off to the side here, I'm going to take this 3x minus y equals 4, and I'm going to move my 3x over. So I get a -y equals a -3x plus 4. And then still, you want to get rid of this negative. You want y all by itself. So just remember the shortcut is I can make this a positive y as long as I change that to a positive and that to a negative. You can change in an algebra equation, you can change any sign you want as long as you change all of the signs. So this first equation became this y equals -3x minus 4. I just solved for y. And so now we know, let me get the screen pen. Now we know y is equal to this, and we can plug that in for y over there. And so this is going to become a -9x plus 3 parentheses. Remember, whatever you're plugging in goes into parentheses. And then inside that parentheses is going to be 3x minus 4. So for this one, we're going to have to distribute. So we get a -9x plus 9x minus 12 equals -12. And you see what happens on this one? The x's cancel out. So just like when we were solving systems back in 0300 and 2.3, when your x's cancel out, if what you're left with, I'll just write it, you don't have to write this down, but if it's a true statement, then your answer is all real numbers, like we talked about on the graphs the other day, or the symbol for that is those two parallel lines. Whoops, I'm not on the camera. Is the two parallel lines made into an R. So if these are the same, it's all real numbers. Now I'm not going to do an example like this, but say the x's canceled out and you had like -3 equals 5. That's a false statement. And so that would be no solution, or a 0 with the line through it. You can write out no solution, or you can write the 0 with the line through it. Either way is fine. If we were graphing these, remember from last time, this would be the exact same line on top of each other, and these would be parallel lines running next to each other. So that's solving systems by substitution.